Getting started. So, guys, did you understand my previous sessions? If you have any questions, you are free to ask. And also suppose you're working in your own project and you are getting some issues in NetApp, you can ping me in the group, and I'll give you the solutions what you need to do. Okay. So today I was planning for the NetApp upgrade. So I'll be going on leave for 13 days, but I will give the training, but I will give official leave. So I was just taking the versions. So for physical array, I went to the ActiveIQ tool and got the versions. But for virtual arrays like software defined storage array, what I did was I went to the support site and just pick the N-1 version and then checked what are the bugs that are fixed in that version and not fixed. So like that. So okay. So these things I will show you how to do. So normally today's topic will be based on cache, front-end ports, and SAN architecture. But normally, let me give you uh, something. 1 second. Suppose you are a NetApp L2 admin, right? So NetApp or maybe storage L2 admin. Storage L2 admin. So what will happen is you'll have both environment in your project, okay? SAN and NAS, okay? SAN is block level arrays, so that means this SAN will be used mainly for high-end applications, OLTP, OLTP applications, database, all these things, okay? And NAS will be used for thing like suppose you are having a financial team, some finance team, they want to keep some PDF or some Excel sheet in some share folder, and they want to centralize, they want to access it, like lot many people want to access the same files and they want to put it there, so and they don't care about the performance, so in that case you will be using NAS, okay? And also for data store, right, VMFS like NFS data store, so for to give storage to ESX you can also use NAS, okay? So SAN will give you better performance. Please mute yourself. Yeah, so SAN will give you better performance, okay? But NAS will not give you that much good performance. So that's why you should not be using NAS for high-end applications. Just for some share folder, you want to keep some files somewhere, and many people are using it. So those things, or maybe you are want to give some storage to your ESX server where which the ESXT will create as a data store, and they don't need high performance. So you can create NFS data store in that case, okay? So what are the activity normally a storage admin will do? First is he will send the health check reports to customer over email, okay? In health check report, what you will have? You will have like if there is any failure, you need to mention the failure, and if there is no failures, no alerts, no severe alerts, then you need to mention as green, okay? And what else you need to do? You need to keep a track about your volume usage. Suppose in NetApp, right? So suppose you are giving a space, right? In NetApp, if you are using SAN, then you will be using LUN, as I said, and the LUN will be created on volume only. If you're using NAS, so you'll be using either CFS, which is used for Windows, or NFS, which is used for Unix operating systems. So in that case also you'll be using volume, and on the top of volume we'll be creating either CFS shares or NFS exports. So you have to make sure the critical applications, whenever it is 80%, more than 80% full, you need to expand the volume, okay? Volume expansion. So this is what you need to do. And also I'll teach you about auto grow feature, like it will expand the volume itself, okay? So that feature also I'll teach you. And one more thing that you normally do is that suppose you have a 100 TB volume or 90 TB volume, but there are a lot of users. What they want is they don't want the 100 TB volume, they want 5 TB or 5 GB data. So what you do, you partition the volumes, okay? You partition the volumes into queue trees, Okay, so and then you place quota on that. Quota means you restrict the size that that particular queue tree have, and then if the queue tree is full, you need to increase the size of queue tree. Okay, so queue tree size expansion or increase. Okay, this kind of request normally L2 will get. Okay, so health check reports, this one, what else will get? uh, Storage upgrade also, they will, you need to do, although you are a L2, still you need to do storage upgrade, so which is a very easy thing. I will teach you that. Okay, and you'll be asked to do zoning. Okay, for SAN you'll be asked to do zoning. So zoning can be you can have like either Cisco SAN switches, or you can have Brocket SAN switches. Okay, so zoning is only used for SAN and IPsy. There are two protocols I taught you. Okay, in last classes there are two protocols for mainly used, which is IPsy and iSCSI. There are some other protocol also which is not much used. So IPsy you use SAN switches, iSCSI you use Ethernet switches. Ethernet switches means network switches which are managed by your network team. Okay, that means what? For IPsy you need to do zoning, for iSCSI you don't need to do zoning. Okay, but the performance in IPsy is better compared to iSCSI, because in IPsy the cable that you use is fiber cables, and iSCSI the cable you use is copper cables, and copper cables are not that much good in they do not have that much transfer speed as compared to fiber cables. Okay, so you need to do zoning. So I'll show a lot of things about switches, zoning and all, but I'll show you Brocket. Okay, in case if somebody is using Cisco and they find some difficulty, I will help you on Cisco also, no problem. Okay, and apart from zoning, so zoning, you are only doing zoning whenever you are getting a new allocation request. New request means a server that is not part of the SAN infrastructure. You are allocating storage for the first time, then only you need to do zoning. If you already allocated some storage from the storage array to the server, you don't need to do zoning. So the zoning is one time activity for the server. Okay, it's just a one time activity. Okay, it's IPsy. And then what they will ask you, they will ask you to do LAN allocation. Okay, LAN allocation, they will call it as LAN allocation. They will also call it as provisioning. They'll also call it as masking, LAN masking. So these are different team. They'll also terminologies. Okay, different terminologies, and they will also call it as give me some space. Okay, allocate some space. Allocate space. They can also space allocation. They can also say space allocation. Okay, these are for SAN. Okay, this is for SAN. For NAS, what they will ask you is, they will ask you to do CFA share kit. They would require a new CFA share, or they will require, this is for Windows, they will require, or they will require NFS exports for Unix. Okay, so here Windows, Unix, these are open systems. These are called as open systems. You also have mainframe, but mainframe storage is different. They use different topologies. They use FICON topologies. Mainframe uses FICON topologies. We don't use that. We use IPsy. Okay, so mainframe storage admin is different, and if somebody knows mainframe storage, right, he will get a lot of salary. He will get 40 lakhs, 50 lakhs also, but nobody will teach you that. That's the problem. Okay, only the people who are like very old, they know this storage, or some people who are very lucky, so they will know mainframe storage. Okay, and what else? So you create this, and one more thing, এটা দরজাটা বন্ধ করো, বন্ধ করো দরজা. So one more thing is there. So this is, you create the shares, you create the exports. Okay, what else? Sometimes your Unix team will do mistakes. Suppose they are using some export, right, and you have given permissions like for some Unix server, right, still they will try to mount in other server and say that because of juniors, right, so they will say no, it's not working, there is some issue, and they will raise a peon request, although that's wrong. So you have to tell them that it should be peon request. So your job is whenever somebody raises wrong P1, your job is to downgrade the P1 to P3 after talking to them, so that management is not looking over your shoulder. Okay, so you have to do that. So if the permission is there, so you have to fix uh, permission issue, permissions, like not permission, I would say, like access issue, I would say, access or mount issues. Mount issues, okay, for NFS exports. Okay, so they will ask you this. What else? Yeah, another thing they will ask you is, they will ask you to see, once you create the CFA share, right, they might ask you to create some subfolders, so where you can limit the space usage. So that in that case you need to create some Q tree. Okay, so Q tree creation, they will ask you this, the Wintel team. Okay, what else they will ask you? uh, LG works, zoning allocations. Yeah, they will ask you about replication for L2 also, but normally for L2 they will ask you volume level application. Okay, volume level application, replication. Okay, so in that case what you need to do, you need to set up the replication, and also you need to do DR testing quarterly you need to do DR testing. So every quarter what it will do, you need to break the your replication pair, you need to mount your target volume to on the application server, and the application team will check whether the data consistency is there, and if they are able to run the production in the DR side. And then what you will do, you need to resync the data from production to DR. In case of real disaster, when the production volume is corrupted, then you have to reverse resync from your target to production. But during the time of DR testing, you don't do that, you do from production to DR. Okay, so this thing you need to do. There are many other things you need to do. Once, let me think. And more things is that you have to acknowledge the tickets, acknowledge the store tickets, so that it does not get breached. Okay, so this is something also you need to do. And another thing is that you have to make sure that you always take mail confirmation for the work you do. Okay, verbal confirmation is not enough. And also you will get some reclaim request for SAN, mostly for SAN. So what you need to do, you need to remove the LUNs from your iGroups, delete the iGroups, then delete the zoning. So all these things you have to do in reclaim. Okay, so what more you can get? 1 second.
You can also talk about quotas.
Yeah. Q3, yes. So Q3 will here only quota will come. So you need to create Q3 and you need to give quotas. Okay, so that you can limit the size of the Q3. So this is same thing you can do. Okay, and what else? Yeah, this thing also you have to do. So you have to know about auto support. Okay, because before the update you need to send auto support to NetApp. Okay, so you need to know that. So these are the main things that you do as normally for L2. For L3 the list will be very long. Okay,
How about
the only
mixed
thing,
protocol there? Mixed protocol, NTFS and
yeah, mixed protocol also you can use. You can use whenever you're creating a volume, you can use security style as mixed, and you can use the same volume to have CFA shares and interface export. You can do that. Okay, and one more thing you can do is username mapping. So name mapping means you want your Windows user to access this Unix like exports, so you can do that. So user mapping or name mapping, that is user mapping, I think that is the terminology. Okay, so you can do that. So so these are the things normal you'll do. Okay, normal you'll do. For L3 I will tell you what you need to do later on. Okay, so the list will be very long. So these are the things normal you'll do. You will get mostly the tickets you will get is this one. These tickets will get lot, yeah, Q3 and quota, and this one. Q3 size increase means what? This is quota only. This is quota only, okay? So this is you'll get normally. Okay. Normally you'll get these things, and for yeah, so for L3, the list will be this long, okay? There are a lot of things you need to do. I'll tell you. Mostly it will be on migrations, replications, installations, okay? But even though you are L2, you have to be very good in networking. I don't know why it's not working. 1 second. Yeah, you have to be very good in network basics in NetApp, okay? I'll teach you all these things. So let's start on the today's class. So we talked about SAN, right? So SAN basically it's a block storage, okay? So basically the SAN storage or block storage, it will store and manage the data in blocks, okay, and which will be accessed via low level protocols like SCSI and NVMe commands. So you have to understand that. And the SAN protocols will provide the block access over the network. So if it's using network switches means iSCSI, and if it's using EPC protocol, then it will be using SAN switches. So whenever the user or the application is accessing the SAN storage, it will access like it's accessing a local disk, so it will not be able to differentiate, okay? And I said SAN is for database, NAS is for like centralized shares, or you can say like data store all, okay? So whenever you are using block storage, right, so you are basically not having any overhead, okay? You are not having any abstraction or anything, okay? So basically whenever this sharing of your learn or any kind of security or multi-user access, those things, okay, those things are normally handled by the operating system, okay, not storage, okay? So you have to understand that. And block storage is very good when you want good performance, okay? So when you want a very good performance, so you should use block storage, okay? So the use case of block storage is basically an application which wants very good performance. It can be database, it can be a like transactional applications, okay? And normally when you use block storage, the block storage you will use whenever the client and the storage both are located in same physical location, then only you will use block storage, okay? Whenever there is a distance between the server and storage, your performance will be impacted. So you have to make sure that, suppose you're using your data center is in Mumbai, right, and you want to allocate some space or use some space from SAN storage, so you will be giving the space of the server which are in Mumbai, okay, same locations, okay, same data center, I would say, okay? And what about file storages? I also discussed last classes what are blocks, what are something, okay? So you just go through the session, and one thing you won't be able to change the block size, okay? It is not possible. It's pre-engineered by your storage vendor, so you cannot change it, okay? So file storage is also called as NAS storage, NAS, network attached storage. Thing is, it's easy to the person who will give the L2 interviews will try to switch for L2 jobs, right? He has to be good in basics, because normally they will try to ask you a lot of basics, but the person who is going for the L2 interview, they will ask you mostly about troubleshooting, okay? They won't ask you basic questions that much, unless that is it depends on the interviewer, but normally they won't ask, okay? So file storage, okay, NAS, so they will call it as NAS. So that means what? You are storing the data in a file system. Basically you will be creating a centralized file system, and that file system will be accessed by many servers, or I would say many users, okay? So it's similar to this hierarchy will be similar to, like, suppose you are having a folder, you created a Windows folder and you have subfolders or directories in case of Unix. So this file storage is similar to that hierarchy, okay, or hierarchy. So whenever the user application wants to connect to the file system, like centralized NAS, share, then they can do using a share like CFS protocol in case of Windows, and NFS, like they can mount the export to your Unix client using NFS protocol. Okay, and you have to make
Uh,
sure for yeah, yeah,
I
tell me.
have one question.
Yeah.
Sir, in the starting application team give me cabling in the server and give us system. So how we decided कि it will be SAN or कि we will be configure NAS in the initial state? How we will identify कि we will
Your
configure SAN or
application
we
name
will
gives, right? So
मतलब
what you can ask is, yeah.
first we get fresh system na fresh
Hmm.
connectivity
Hmm.
and fresh connectivity from the application team that we need a new configuration from the storage side. So how we will decide that it will be SAN or it will be NAS? How SAN communicate, how NAS communicate? It is different way communicate or same way communicate through WPA number?
No,
How?
no, it communicates very differently. I think second session I showed you SAN and NAS architecture, how the SAN, how the HBAs are used, HBAs are connected to your switches, and also the FC ports are connected from the controllers, and how we do zoning. I showed you like an overview, and for Ethernet architecture, like for NAS, I showed you that Ethernet ports of NetApp controllers are connected to Ethernet switches, and we connect the NIC ports from servers to the Ethernet switches. So if you are using SAN, you need to do cabling, like not you, your data center team needs to do cabling from your server HBS to your SAN switches. So they will tell you, suppose they came to you, right, for an application, you have to ask them what is the workload characteristic, okay? You need to ask them what would be the IOPS, what would be the record IOPS. Depending on IOPS, if the IOPS requirement is big, and you will ask them what would be the latency. If the latency they're asking like less than 15 millisecond or 5 millisecond, then you should go for SAN. Okay, and if they're asking like, they will tell you, they will tell you that I don't need a high performance thing, I just need some share where I need to put the data. They will tell you, because your client is very smart. They don't, because SAN will cost you big. SAN is expensive, NAS is cheap, so they would always want to reduce the cost. Okay, so they will tell you that I need LUN, or they will tell you that I need storage from SAN, and they will tell you that I need a share. They'll explicitly they will tell you that I need a share. So when they need a share, what you need to do? What is the first thing you need to do? You need to make sure the server is discoverable by the network. Okay, and what you do? You need to make sure that you know the VLAN where the server is in VLAN. Okay, and you have the same logical IPs lives created in your NetApp that is in same VLAN. Okay, and what you need to do? You need to create shares, and you need to give the path. If it's a Windows host, you need to give the shares, and you need to give the path to them. Okay, in the second class I showed you the IP colons, like slash the path name, volume name, that you need to give for NFS exports. For Windows it will be like IP slash your volume name. Okay, and you need to mount it as a network drives in Windows operating system. Okay, so you'd know they will tell you that I need a share or I need a LUN. They will tell you, so you don't have to worry about that. If they tell you that I need a SAN or I need a LUN, then you have to check whether any LUN has been given to the server previously. If it is not given, then you have to do zoning. First time you have to always do zoning, and I will, in the zoning class I will show you that the mistakes normally the freshers do, or the 2 years CS experience does, which can cost them big, because there is something you don't do. If you do that, you lose your project or job. Okay, so I'll tell you what you not to do in the zoning class. Okay, so what I
Or
was telling.
so
Yeah.
sometime we got request from the user side for space allocations. So there is a mention कि 512 sector. So we decided कि need to give space from 3 par side, 3 par storage side. Sometime there is mention 4096. So our team members मतलब suggest me give space from NetApp side. So what is this? How we define कि it is for 3 par, it is for NetApp?
Yeah, so it depends on the data center. Suppose you have different data center. Suppose you are working in a China data center, you have a Chinese data center, and the China data center, the servers you are having, it's only having 3 par, so you give from 3 par. You have a Mumbai data center, there you have NetApp, give from NetApp. and also it depends on space, and also it depends on the in when you work in a project, right? So you'll have a document that is HLD and LLD, high level design and low level design. In the high level design, it will give you an example like whenever you're getting a request, so what will be the storage you need to select. So it you have to get a good KT, then only you can decide. Okay, so
Uh,
that is project
means
specific. That's not technical specific. That is project specific. What storage you use, that is project specific. In
I
my case, I will
think
tell you. Okay.
I want to ask what is 512 sector in 3PAR and what is 409 sector in NetApp. I want to what is this?
There is nothing. I have never worked in three part, but there is nothing called 4019 sector in NetApp. So you might
Okay.
be telling this serial number. Okay, you might be.
It is not, it is
Please.
mentioned sector. So we decided ki need to give space from NetApp, and if there is mention in the request for
So it means
512,
okay. I understand. So maybe the sector means that your location. It can be the location, data center location,
Yeah, I
maybe.
think it's rack location they have mentioned.
or yeah, or rack location.
Might be.
Yes. But it there is no term. Sector is there. Sector technology is there, but sector is in hard disk. Okay, not for storage array. There is no such thing sector in storage array. At least not for NetApp, Hitachi, or EMC. I have never worked on HP 3 but NetApp, Hitachi, and EMC there is no concept of sector in storage array. Okay.
Okay, it means not such types of term, na? It's
No,
only
it's a not project specific. It says
okay.
project specific. So if you go to some other project, you may not find that term.
Okay, thank you, sir.
Yeah. So, and one more thing, you have to be very smart. Smart means whenever you get KT right, you need to ask them to record the sessions. The reason being, sometimes people will deliberately give you wrong KT so that you can do mistakes. My friend used to do that, okay? So they will do that, okay? So what you need to do whenever they are giving KT right, you always ask them to record the session. And sometimes they will not give you the KT properly and they will say that they have given you. And they will have good connection with the manager, right? So they will say, no, I've given you, this guy does not know anything, even though you know, even though you have knowledge. Because this is Indian politics, and that is the reason, a lot of people are unhappy in their jobs and they change the job or project. So you have to be very smart, yeah, and you have to talk as much less possible with senior managers or managers. Yeah, normally. Okay. So anyway, so what I was telling, yeah, in this project, right, I'm working, right. So the person, the entire team was removed, okay, because they did not do good work. So they were like very angry. They didn't give KT at all. When you ask them to give the KT on NetApp, they said I don't know NetApp, and they just left. Okay, so they might, they might do like such kind of things. So anyway, KT means not technical KT. KT means there are two KTs. Technical KT means they will share the technical knowledge. One is environmental KT. Environmental KT, they will tell you these are the arrays we have. Suppose you get allocation equals, so this is China data center. We have this data center. This is how this is architecturally this is connected. Here we're using NAS. Here we're using SAN. Like this kind of thing they will tell. So which you can also find out on your own, but you have to work a lot for that. Like you have to log in here and there. Okay. So what I said for Windows, you'll be using CIFS, okay? CIFS or SMB protocol. I said the CIFS and sorry, SMB and CIFS are not same, but now we change it, like we use it interchangeably, but it was different. Initially, the CIFS, I think SMB protocol was invented, and then the CIFS, okay? But if somebody is saying SMB or CIFS, it means same nowadays, okay? So this is share. You call it as share, okay? Windows team can do another thing. Instead of using NAS product, they can have a Windows server, and there they can create a share like CFS server, and they can use that server like mount the space from that server to other servers. Okay, but that has limitations. That will not have very good performance compared to NAS storage that we have in NetApp or any other NAS storage. Okay, I used to use this like not Windows but Linux. Linux also same thing. So for Linux you use is NFS protocol, okay? and there what you do, you create the export from NetApp side, okay, and you mount the export in Unix as a directory on a directory, okay, on a directory, and then the Unix team will give some permissions, like I showed you two commands: chown command, change ownership, and chmod. Chmod will give like read, write, execute on that directories. Chown will give you like who's the user owner, who's the group owner, and who's the other user, like what will be the other permissions. So those things, okay, you don't have to know that, but the L3 does, because for L3 the interview, if they're giving you like 30 lakh salary, right, so they would want that you know well, okay. One of my friend, right, Rahul, his name is Rahul Dandamudi, he's from Telugu only, Andhra only, so he used to work with me in Hitachi Vantara. Now he is working in one of the top, I forgot the company name, but he's in Switzerland for long time. He's a manager, he manages storage, VMware cloud, everything, okay. So there are a lot of things. So when you get more than 12 years or 15 years experience, you should know storage, VMware, backup, cloud, and automations. If you know networking, then very good. But networking is not an easy thing to study, okay? It will take some time. And you have to always make sure, suppose you want to map a CFA share, right? There are some ports. I will check the ports, okay? I don't remember the ports, okay? So that ports has to be open from your NetApp. So NetApp cluster management leaf, or NetApp, not cluster management leaf, NetApp, the data leaf. Okay, the data leaf will be the source, and your destination will be like target IP will be your Windows servers, okay, and the ports will be like, I think it will be TCP, and unidirectional. The like from and to, from will be your NetApp, and to will be your server. I will tell you more about this leaf and all when you start the NetApp sessions. I'm just giving an overview, okay. Leaf, you can call it like an IP for NAS, okay. It's an IP tied to a port.
Oh, this CFS
NAS.
shares also we can mount to Linux server, right? Some technologies there, right?
You can do, yeah, you can do, yeah. User mapping, you can do that. Samba technology, Samba.
Samba,
It
okay.
called is Samba, yeah. This is their Samba, but it was there previously also 2011. So I created some shares, and then I created Samba like I did, but that Samba was different, like not on storage. This is storage, and also you can do that. So I will show you that one also, okay.
Yeah.
And then for
Yeah,
L3 you need to do DNS,
yeah,
IP based load balancing, lot of different things. Yeah. Please ask the questions. Yeah.
yeah, yeah. Actually, one interview I have given. So in that interview, I'm not aware of that question she asked. She asked me that if I am using SMB share, so is it possible to convert it into NFS? So what is the process? She asked me. I don't know about it. So I said I'm not aware of it. So is it possible to convert from SMB to NFS?
Yeah, it is possible. It is possible to do that. Okay. It is possible
Okay.
to do that. So suppose you have a volume, you create a mixed volume, and then on the mixed volume, you create a CFS share, LFS export, or you can also mount your CFS share to Unix file system. That is user mapping concept. So I'll teach you that in the when I start the NetApp, right? So I'll teach you all the steps. Okay, I will draw a flow chart and show this. This is possible. Okay, but
Okay.
in that interview they would ask you leaf, right? Have they asked you leaf? What is leaf?
Yeah, yeah, yeah.
Logical interface.
They have. Yeah, yeah. That
Leaf they
I
will
know.
ask you,
Yes.
because
Hmm.
this is the granular things, like fundamental thing. Without this you cannot do anything. And Mahesh, right, one of my trainees, right, he came to me about two issues, right. Both the issues were related to leaves. He changed the SFP of his storage port, although he changed, but still it was showing as degraded in VLAN. Okay, so because the leaves are not in home port, so I'll show you all these things. But you have to, whenever I'm showing a one class, right, these classes are easy, but when I'm showing data class, right, you have to at least view the video 5 times to understand.
Yeah, yeah. Yes.
You need to, yeah. For L3 people, the training will go on forever, 3.5 months. It will like, but I do not suggest the less than 5 years experience to go for L3. Okay, because whatever you learn well. Because otherwise you won't be able to tell during the interview. you have to, they will ask you a lot of basic things. They would want to know whether you really work or you have just acquired the knowledge from Udemy. Okay, so they might ask you this. But for Hitachi, it's easy to crack the interview because Hitachi materials are not available. So anyway, so here you need to open the ports, as I said. For NFS also you need to open the port. Okay, and there are two ports that need to open. So one is NFSD. This is NFSD daemon. Okay, daemon. So in Linux or Unix, there are daemons there. Daemons services in the /etc/services directory. Suppose you are installing something, right? Any application. So those services will be there. Suppose FTP protocol, right? So FTP services, your syslog services, all the services will be /etc/services directory. Okay, so NFSD daemon will be there, and they call it as daemon also. So this 111 port, and then mount the port. Okay, 2096 or 2046. I just check that one. Okay, so these two ports you have to open from your NetApp to your Unix server. Okay, and it should be like TCP, and you do it bidirectional. Okay, normally unidirectional will also work, but I do it bidirectional. Okay, so bidirectional you need to open. So your source would be your NetApp data leaf. Okay, I will tell you what is data leaf, and target will be Unix server. Actually I caught some cold, so that's why, I was okay when I went to office today, but when I woke up from my sleeps, and then I'm having some cough. I'm not changing the company. The reason being, this project is very good. I can sleep. So it's not a problem. So I can sleep during the afternoon also. So it's not a problem. That's why I'm not changing my company. And also I'm in home location, so that's why. Otherwise, Hyderabad would be my preferred location. Hyderabad or Pune. Anyway, so you see this, right? So these ports you need to open only if whenever your data leaf and your Unix server IP, those are not in same network. If it is same network, then there is no firewall in between. You don't need to open any ports. Okay. And after opening ports, suppose whenever you create an NFS exports, Unix team is trying to mount the NFS export on the Unix server, they're getting some mount issues. Then what you do, you ask them to do telnet, then give the data leaf IP, okay, and then give the port number. So if they see like connection refuse, that means the port is blocked on the firewall. So they need to open a firewall request on the service now. They need to follow up with the network team, and they need to get the port open. Okay, so once the request comes through, the firewall team, anyway, when you raise the request, the firewall team will see that yes, they got some connection refused request in the firewall. So they will open it. Okay, so these are the main. I will tell you a lot of troubleshooting, so that will help you to get the job, because troubleshooting is all the things. Suppose right now I'm going to upgrade, right? So my upgrade code. Okay, so I'm upgrading the code from 9.13 or 14, I think 9.14.1 P9 to 9.16.1 RC1. So that is resolving me 6 risk. Okay, but 70 risk are not resolved. Like a lot of risk are resolved. Like sometimes because of bug, the SMBOS CIFS client will get connection denied or access denied, wrong password entry. Okay, even though the password they're giving is correct. So this is one bug. Another bug is that the energy, like how do I say this, the temperature will be more. Okay, so it will reduce the carbon footprint, but going to the lesser temperature when you go to the UR code. So there are a lot of things are there. Okay, there are 4 more risks are there. So what I do, suppose you are going to do an interview, right? So we'll try the current codes and what are the codes, the fixes. Okay, so they will ask you during the interview. So okay, so what is the current code you are running, and what are the vulnerabilities you have in the current code? So they will ask you. Why they will ask you? They would want to know whether you really work in storage or not. You cannot get that from Udemy course. Okay, so this is something. Okay, so let me go more about this thing. 1 second. So yes, quotas also they will ask. Okay, let me go. Yeah, so this is basically the components of a storage system. Okay, it can be a mid-range storage array, it can be a high-end storage array, it can be a entry level storage arrays. Okay, higher storage arrays basically AFF, all flash arrays. Mid range are basically FAS. FAS means where you can use different type of disks like SAS, SATA, and SSD. I talked about different disk terminologies, what are the RPMs and all these things. Okay, in my first class, you can go to the first class. In NetApp they use BSAS, which is like the form factor is 3.5 inch. Okay, and in Hitachi we use NLSAS, 2.5 inch disk size also tied to capacity, big disk, big capacity. Okay, so in storage the main thing that you have to understand is these front end ports. For SAN you have to do zoning of your HBA. Okay, HBA with your, so normally you'll do soft zoning. Soft zoning means WLPN zoning. WLPN zoning, worldwide port numbers. I'll discuss you all these things. Okay, don't worry. I'll clear all the basics of storage before moving to the NetApp classes. Okay, and even also my one of my senior guy, like senior person, so he's teaching IBM and HP, and one of my friend who works in HCL, so he is teaching, he will be, I have requested him, so he will teach iSCLN. So some, I know a lot of people will be interested iSCLN because it's a very good storage. Okay, so I'm trying to bring more people for storage and backup and VMware background, or maybe the whole infrastructure. So trying to get, but at least I'm trying to get people who are, the minimum experience they have is 12 years on that product, 10 to 12 years. Okay, this guy is like HP guy is having 70 years of experience. He's very good. Yeah. So yeah, please be clear. So here, yeah. So normally the thing that you have to understand is whenever you're doing SAN, right, you have to do zoning. First you have to connect your front end ports from your storage controllers. So every storage it will be having controllers. Okay, in NetApp we call it as nodes. It can be a 2-node cluster. If you're using only for like testing or development environment where you do not care about the redundancy but you care about the cost, so in that case you need 1-node cluster. 1-node cluster means high availability is not there, means if the node is down the host will lose access to storage. Okay, but you're going to use only for testing and development, not for production. So what you do for SAN, you have the FC ports, you connect the FC ports with fiber cable from your storage controllers or storage node to your SAN switches. I also discuss about fabrics. Fabric is collection of switches. Okay, and I'll discuss about core edge fabric, full mesh, partial mesh, all these things. So suppose you connect it to a switch, right? So you connect to a switch using fiber cables, and then you connect the host HBA to the switch. Okay, and then you do zoning between the WLPN numbers, using WLPN numbers of HBA with your front end ports WLPN numbers. Okay, and for redundancy purpose every host will have at least 2 HBAs. So because one HBA is down, you still have the access from the other HBA. One fabric is down, you still have the access from the other fabric. One front end port is down, you still have the access to the from the other front end port. One controller is down, still have the access from the other controller. So what you are trying as a storage admin, your main job is to eradicate single point of failure. Single point of failure can be on fabric level like switch level, it can be on host level, it can be on storage level. Okay, that is your job. And for SAN also you need to install multipathing software. I told you NetApp we use native multipathing. Native multipathing means that comes with the operating system. For Windows it is MPIO, for Linux it is multipath D. Multipath D is the daemon. Okay, which will be when you install this, you can look at the file, the configuration file of multipath D /etc/multipathd.conf. I had one issues in bare metal, so I had to disable some IDs of some logical volumes. So during the time of booting, because of the logical volumes, I was having some problems with the Linux. Okay, the Linux was having limitations during, that was RHEL 5. Now we are using probably RHEL 9 or maybe RHEL 10. So, and so you have to understand. So thing is, I will tell you one thing, learning infrastructure is very easy compared to development. It is very easy. You just have to understand the basic things. Once you understand the basic things, then you can learn anything. So basic thing is more important. So you have to understand front-end port, you have to understand HBA, you are doing zoning. If it is a NAS, then these ports, these front-end ports will be Ethernet ports, and here you will use NIC, Network Interface Card, and there is a card converged adapter, CNA. It will come with both NIC and HBA. Okay, but here suppose you're using NIC, right? So you'll be connecting NIC to your Ethernet switches. Here for your NAS you don't do zoning. For only SAN, FC you do zoning. No zoning for NAS. Okay, you don't do zoning. And NAS infrastructure, most of the infrastructure will be managed by the network team. They have to be better, otherwise you will get a lot of performance issues. Okay, so you are doing zoning between the front WLPN number of front end port with your HB WLPN number. You can also do hard zoning, but hard zoning is, although it's more secure, but it's not used anywhere. I have only seen it's in use in some project, but they wrongly used it. Somebody probably did some testing on that just to increase his knowledge. So, but it's not used. And mix zoning is also there, right? Mix zoning, but you don't use that. Okay, so use only WLPN zoning. They will ask you what is the difference between soft zoning and hard zoning. Okay, I will tell you in a zoning class. So I will tell you all the things that they will ask you in the interview. Okay, all the things about basics, but you have to know one thing. You cannot even if you know the answers, you should not say 100%, because more questions you will answer, they will ask you more. They will ask you to a point whenever you are not able to speak. Okay, you don't want that. So this you see storage network. Storage network means what? This is SAN switches. Okay, this is a fabric. So this intelligent storage system, which is a high-end storage system, right? So this storage system will have 4 components: front-end ports, cache. Cache you can call it as like laptop. We have RAM, right? Desktop. Our old personal laptop we have RAM, right? So random access memory. So like that cache. Okay. Then we have backend ports. Okay, and we have physical disk. Okay. You can see this. Whenever host is giving you some input output request, they want to do IO. So I told you what is IO, and read request can be IO, a write request can be IO. I told you in third class. Okay, third session. You can go through the session. Okay.
Excuse me,
So
sir.
whenever, yeah, hello.
Sorry, this intelligent storage system, sir, this configuration is same for the Dell EMC is as well.
Yeah, everything. Dell EMC, like Hitachi, NetApp, all the storages, it's same.
So, sir, that means like front end and back end are same, right? Like on back end we have disk, and on front end we have the host connected, right?
Yes, yes, yes. It's same, but the architecture will be different, and also some technologies will be different. I will tell you that. SAS backend, NVMe backend. Previously in 2015, 18, 19, we used to use SAS backend. Now NVMe backend. So some protocols will be different, but this thing is same. These all the things will be there. In Hitachi, they will call it
Okay.
as cache. Okay, global cache. In NetApp, they will call it as NVRAM. The names are different. Okay,
Oh, and
but
sir, one more thing. Oh, sorry, carry on.
yeah. Okay, so suppose you get input output request from your host. Okay, you got this. So initially it will be transferred to your front end ports. Okay, you'll get this front end ports. This from this front end port it will go to the cache. Okay, and then it will from the backend ports it will go to the disk. Okay, and suppose it's a read request, what it will do, the read request will go from your host team from switches to your front end ports, and then the front end ports will do the control operation, the processor in the front end port. So what it will do, you will try to find the data in cache. If it is already in the cache, so data will be copied from the cache to the host by the front end ports. Okay, but if it is not in the cache, then what will happen? From physical disk, the controller of the backend ports, it will stage the data to cache, and then front end port will copy the data from cache to the host. Okay, so in that case, suppose the latency here 5 millisecond, so here the latency will be 20 milliseconds. So 4 times the latency will be higher. Latency means how much time it is taking for the host to access the data from storage array. Okay, latency, it will be measured in terms of milliseconds, ms. So it's better if it is 1 millisecond, less than 5 millisecond, 1 millisecond, 2 millisecond. Some applications which you can which they don't want that much performance, so you can also use 50 millisecond. But more than 50 millisecond, if it goes like 50 millisecond something, then you'll be start having performance issues, you'll be start getting performance calls. So when you get performance issues or calls, the first thing you have to check is latency. Using that latency graph, you'll be able to identify whether it's a storage issue. If it's a SAN switch, it's very easy to identify. If it's a NAS, then the troubleshooting will be different. Okay, I will show you that. I will show this. Okay, so for L2 guys, what I tell you, you take my training, switch your job, work there for 1 or 2 years, then take my L3 training. You just have to pay 10k extra, that's it. So you just do that, because what I don't want you to learn L3 at one go. The reason being, you will not be able to remember all the things. That's the problem. It will be very difficult to remember. Okay.
Sir,
So-
can you please tell MPIOB that you just said before? What is the spelling of MPIOB?
Yeah. MPIOB?
Yes, sir.
MPIO? This one?
Yeah. Okay.
So
And sir, what is the full
multipathing
form?
software. So multipathing software, okay?
Okay.
I think it is multipath input output. I don't know the full form of this, but MPI is used for Windows, and multipath,
Okay.
it's used for multipath D used for Linux. RHL. Let's say RHL, not CentOS. It's basically multipathing software. Even though you have connected your two HBAs with different fabrics, different fronted ports, still you will not get multipathing. Like the workload will not be going to the both the paths. Okay, so for that you need to install multipath. It can be a native multipathing. Native means that comes pre-packaged with your operating system. MPI for Windows and multipath for RHL. If it is proprietary, like in case of Hitachi, they call it as HDLM. Hitachi Dynamic Link Manager. Okay, in long time back, we also have another product, Global Link Manager, GLM, using which you can monitor all the HDLMs in your environment, but that is not used nowadays. For EMC, you'll use PowerPath. Okay, you'll use PowerPath, but these are storage given, like vendors, storage specific. Okay, but this thing is not storage agnostic. You can use for any storages. This is native multipathing. Okay, normally we use this if you have multiple products like NetApp, Hitachi, EMC, and you are allocating in one host, you are allocating for different storages, then you use native multipathing like this. Okay, I think it is multipath input output. I have to check it, but nobody will ask you the full form MPIO. Okay, so you need to make sure, as a storage, you need to make sure your server team configures this. Okay, otherwise when you do some switch upgrade, I'll also teach you switch upgrade in the L2 training also, because sometimes the L2 guys will be asked that. Okay, sometimes the L2 and L3 is like if you do not have office politics, the L2 team will also be given the L3 task sometimes, but office politics is there, then maybe not. Okay, so did you understand this thing, how the data is processed? And suppose write is happening, right? Suppose a write equals host want to write data to a storage, right? So what it will do, it will go to the SAN switches from front end port, will process the data, and it will write to the cache. If the data is the space is then cache. If the space is not then cache, then what cache will do? It will free up some space. It will distribute the data from cache to your physical disks which are not used frequently, and then it will write the data here in cache. Okay, so that's what it will do. And then at later point of time, in case of if it is NetApp, so in NetApp there is a concept of consistency point.
Hello there.
Yeah,
Cache is the disk or something other than the disk. It is the
no,
part
it's
of disk
you
only.
can call it as like RAM, random access memory, like fast memory. You can memory, cache is memory.
Okay.
Like in laptop you have RAM, right? RAM.
Yes.
You have RAM, also you have hard disk. So this is RAM.
Okay.
Yeah, like RAM, like fast access, very fast access.
तो जितना डेटा कैश का डेटा ज्यादा रहेगा जितना उतना ही it will affect something or cache has the some limited
Yeah,
value
yeah.
will be there.
Limited value will be there. Suppose you have the cache, right, and the cache is full, or cache is full, then you'll face performance issues. You have to understand the limitations of cache, and normally NetApp is a very intelligent vendor, so they will manage the cache well. But suppose you have two controllers, right, in NetApp, so the data will be mirrored from one NVRAM, like they called NVRAM cache as NVRAM in NetApp, so mirrored to other controller. So every controller will have their caches. You understand, right? Every controller, every
Yes.
node or in NetApp will have the cache. I will tell you the architecture of NetApp once I begin this, okay? I'm just giving a basic architecture of all the storage arrays. This is the basic architecture.
Okay.
So
Cache
it
is
will
for
be
fast
NVRAM
access.
only, right?
Yeah, in NetApp is NVRAM. So whenever the NVRAM is half full or 10 second past, the data from NVRAM will be discharged to disk. Okay? This term is called as consistency point, CP, in NetApp. They'll ask you these things, CP. I'll tell you this thing. No, don't worry. I will give you a lot of examples about this. And NetApp, the data flow will be very different. I will tell you like similar to this only, but more things will be added. Okay, this is a basic thing I'm teaching, so that you understand. This is a basic thing. Okay. So here you see the front end port. The front end port used for what? It is used for zoning, for FC SAN, and it is also used for replications. Suppose you want to do replications for SAN level, okay? So what do? You do zoning between the front end ports with your other storage front end port. Your source storage will be there, your target storage will be there. So source storage FC front end port, FC port, and target storage FC port. You zone them, okay? But if you are doing replication between for your NAS storage, then what you do? You connect the Ethernet switches like Ethernet ports from source and target storage to Ethernet switches. You don't do zoning, okay? You love working in NetApp. The reason being, you will get a lot of issues to work on. If you work in Hitachi, then you don't have any work to do, okay? Like you will not get any issues. I saw only 4 to 5 issues in last 10 years in NetApp. Sorry, in Hitachi. But in NetApp, there is something to learn. Kindly, someone please accept everyone, okay? On behalf of me, please accept them. Admit them, yeah. So, yeah, so this is a free teams, okay? फ्री टीम्स में क्या होता है कि हर 1 घंटे के बाद ये खुद से डिस्कनेक्ट हो जाएगा। हर 1 घंटे के बाद खुद से डिस्कनेक्ट हो जाएगा फ्री टीम्स, ओके? मैं पहले क्या करता था शुरू शुरू में, मतलब व्हेन आई स्टार्टेड गिविंग ट्रेनिंग, लाइक आई यूज्ड टू यूज Google Meet, okay? But Google Meet was not good because the voice was not good. So I started using Zoom of one of my trainees, Nanda, who's basically from Kerala, okay? He's very good in storage. He works in Hitachi, NetApp and Pure Storage, okay? So anyway, so this is also good. I don't know why he's not able to accept, but anyway. Admit them. Okay. Yeah. Reward is accepted. Yes. So here, what I'm trying to say is that storage is very easy. Okay. So you can learn everything. It's not a problem. Okay. Please mute your audio. Otherwise, some background noise will come. Yeah. So here you see the front end port, right? Front end ports, right? So what does Not my microphone. Not my microphone, yeah. So here you see the front end port, right? So what does front end port does? So front end port will basically provide the interface between your storage system and the host, okay? So it will do the connectivity from your storage system with host, okay? This front end port will enable the host to connect to the storage system, okay? So this front end port, it will have the processing logic, okay, which will execute the appropriate transport protocol. Suppose you are using SCSI, right? iSCSI, right? So you'll be using iSCSI port. The iSCSI port will support iSCSI protocol. If you're using FCSAN, you'll use fiber channel port, FC ports, okay? So those different ports will support different protocols. If you're using NAS, you'll use Ethernet ports, okay? And you'll be using redundant ports. Redundant ports means you'll be using one port per controller. So if one controller is down, still you have the other controller. From here your host can access your extra storage from that controller, okay? So that you can do. So what FED ports, front end port, they will call it as FED port, FED. In Hitachi they will call it as CHA port, channel adapters. In NetApp, front end port, okay? Front end port, that's it, okay? So what they will do here in
And
front
that
end port, you can
cable,
call
it's
this.
yeah, and that cable is depend on the protocol which we are using, right? For front end.
Yes. If you are using FC, you'll be using fiber cables.
Okay.
Fiber cables. Fiber cables are also multi-mode, single-mode fiber cables. I will tell you what are those, okay? They don't ask you this much, but still I will tell you. And if it is iSCSI, they'll use copper cables, Ethernet cables. If it is NAS, you use Ethernet cables, copper cables, okay? When you
Okay.
used storage during the 2011, right, the speed was like 1 Gbps. Now speed is 10 Gbps, 40 Gbps. So a lot of storage is able to give better performance, okay? And nowadays storage has become so much in trend that they are inventing new plugins for new things like VMware plugins. Today morning I gave a session on automations using cloud orchestrator for Hitachi guys. So there they have some plugin using which you can create the data store, you create the LAN with one go. Like just click on it and there is a workflow, everything will happen, even the allocation will happen, zoning will also happen. So but we don't use those tools frequently, okay? Frequently your client will be dependent on you only. They don't want that much automation in storage, but in Cognizant most of the projects are automated, depends on the company, okay?
So
For the L2
that
guys, I'll give you
port
one
are
suggestion.
port are multi ports or the similar ports are there in front end port.
Yeah, multiple ports. There will be like 32 ports, 42 ports. I'll give you it depends on the model, okay?
Okay.
So you'll have multiple ports, like you'll have some Ethernet ports. You will have some FC and iSCSI ports. Normally an FC and iSCSI use interchangeably. Same FC port will be like used for iSCSI, like they will have the same protocol. Or you can have different ports also. So different port will have different protocols. Okay?
Yeah, so
So
in
when I just
previous class, we have discussed about the license which we have to purchase for the protocols. So, how many means any limitations for server if I purchase the SAN protocol license? So, how many servers or any limitations are there or infinite server
no,
we can?
limitations are there.
Okay,
Limitations are there. Even for volumes also limitations there. But I have to check the limitations, okay?
okay,
For Hitachi, like we can create 65,536 lamps in one storage. Okay, so
okay,
NetApp also the limitations are there. I will tell you the limitations, okay? It's
okay,
like some 20,000 something, but volumes. So I will tell you how many servers also I will tell you, okay? But limitations are there. Even fabric level also limitations are there.
okay, okay.
Limitations are always there. Yeah. So and you have to make sure that you are having multiple paths so that you do not have any single point of failure in case of production, not for testing or development. Testing development, it's okay. So
Yeah,
here,
okay.
what are the front end ports? What front end ports are doing? Front end ports or front end ports in the controllers, they are routing the data to cache. Okay, whenever host is writing some data, or from cache whenever it's a read request, okay? So whenever cache is receiving any write data, right? So first what we'll do, if there is space in cache, so the data is written in the cache, and this front-end controller, it is sending an acknowledgement to the host, telling that your write is completed. Okay, so it is faster access. It will be in 1 millisecond, 2 millisecond. But if it is cache is not having enough space, and it has to discharge some data from cache to physical disk, then the latency will increase by 4 times. That is the that is the testing that NetApp and Hitachi done, that it will increase by 4 times. If it is 1 millisecond, it will become 4 millisecond. Okay. If it is 5 milliseconds, it will become 20 milliseconds whenever you are not getting the data in cache. Okay. And here, this optimization, right? So here there will be like storage queuing will be there. So like whatever input output is coming, right? So there will be a queue depth in HBA. In HBA there will be queue depth number. Queue depth number means how many input output can remain in a queue. Every HB will have some queue depths. Okay, so that many input output will be remain in a queue. So one input output process, then the next input output will be processed like this. If you have 2 paths, then simultaneously 2 input output will be processed. Okay, like that. Okay, input output means IO, and read request can be 1 IO, a write request can be 1 IO. So it's all separate IOs. Okay. So this queuing is this queue depth I talked about, right? Queue depth can be in it will be in every HB will have some queue depth, and also the front end port will have some queue depth number. Okay, you can get it from NetApp side. Normally they won't ask you that, but what is the queue depth? But if they ask you what is queue depth, you can tell them. Okay, it is basically how many how many input outputs can remain in the queue. Okay, so suppose it will have different algorithm. You don't need to that. You don't need to know that. FIFO, all these algorithm will be there. Like first in, first out will be there. Okay, so suppose you are getting some request, right? So whichever request it's coming in the queue first, that is the request will be processed first. Okay, so this thing is there, but they will not ask you about this algorithm. Okay. Here the cache, right? Cache. Here I'm talking about some very important things in cache. Okay, you can call it cache like RAM. In laptop we use DRAM, dynamic RAM. Okay, in NetApp NVRAM. Okay, which is non-volatile RAM. Okay, and also we'll have like vaulting and all. Vaulting means suppose your storage system got shut down, right? So whatever data is in cache, it will be lost, right? So there is a mechanism so that the data is not lost in the cache, even though when the storage system gets any power, like data center where the storage system resides gets a power outage, still you'll have the data saved. Okay, it's vaulting. EMC invented the technology. Okay, vaulting. Back in 2000, from 2011 to 2019, I worked a lot of in EMC products, but now EMC is not that much popular. I think even the pure storage, which is only 10 years old or 8 years old, that is becoming very popular because of the cost. And I like Hitachi because in Hitachi, whenever you walk in Hitachi, right, you can enjoy your life. You will not get any P1, P2s. Not a single P1, P2 will get. Okay.
Sir, what is the spelling of vaulting?
VAULT.
Okay.
VAULT. See, I'm a Bengali guy, so I have a pronunciation problem between V and B. So that's it. I say V and B, same thing. Okay, it's same for me. I'm not able to pronounce V. Okay, that's the thing. So,
Sir, as you're saying that in Hitachi we don't get P1 and P2, so is it good for the banking environments also, like for the very critical?
it's very good for the banking environment. Normally, banking environment they will have Hitachi products.
Okay.
They will always use SAN for Hitachi and NAS for NetApp. They will not use SAN like if they want to use SAN, they won't use NetApp. They use Hitachi or EMC or Pure. Even Pure is good. NetApp is not good for SAN. And similar to NAS, Hitachi is not good for NAS. Hitachi, the product is HNAS, and now they have another product, OneFile, which they have recently invented. Okay, in Hitachi, I was a team where I used to, I worked in different teams. One is SAN migration team, one there I used to only do migrations and replications. Then I went to some different team where I used to install softwares and application, and then give KT and come out of the project. So that is different. but I would suggest you to work in one vendor company just to have that on your resume, but stay in services company for many years. The reason being, you have to do a lot of work in vendor companies, bro, which is not good for your health. You don't want that. Okay, so in Hitachi I used to work like 14 hours, but I had only work during weekends. There was no work for me during Monday to Friday. Only Saturday, Sunday I used to do work. Okay, so anyway, so what is cache basically? Let me go to this picture, not here, here, this is cache. Okay, so cache is basically, this is an important component, okay, which will enhance the improvable performance. Okay, is basically, it can be a DRAM memory or it can be a programmable level like VLSI, right? FPGA. Okay, so they won't ask you this. I discussed about this in my first class. So normally, we used to use DDR2, DDR3, then FPGA like programmable RAM came. Okay, so nowadays it's like NVRAM. Okay, so so here, why we are using cache? Because we want to enhance the improved performance in the storage system. Okay, so cache is basically, it's a memory, you can say. It's kind of like RAM, what is in laptop. Suppose your input output request is coming, right? So data will be placed temporarily in this cache. Okay, so that the time required to service the input output from the storage system, it reduces, because whenever the data is written in here, so immediately the host is getting an acknowledgement that write is completed. So host is getting faster response from the storage system, so which is improving your performance. Whenever you are getting any issues in storage time, they will call it as performance bottleneck, latency issues. Vinay. Okay,
Sir,
performance bottleneck. Okay.
sir, generally, what is the size of cache?
I will tell you that. Okay, I just need to check, but in Hitachi is like 512 GB. In case of VSP 5100H, so every model will be different. I'll just tell you and check that. It will be terms of GB. Okay, it can be like 1 TB also. I will just tell you, I'll just check the specifications on all flash array, and I will tell you that. Okay, so 1 second. So cache of EFF array, EFF 250 array in NetApp. Cache size, I would say, mostly. Yeah. So 1 second, what is this? Maximum scale. So you can see here this having to do 24 nodes, 12 HA pairs. So they haven't mentioned this here. They haven't mentioned this here. Okay. So anyway, so I'll just search and tell you. Okay. Later on I'll search and tell you. They should have mentioned here, but they didn't mention anything here. Okay. Anyway. So they mentioned here what? They mentioned here how many maximum SSDs you can have. Okay, which is non-mechanical disk, solid state drive. So you can have 576. They mentioned how many nodes you can have. Mostly 24 nodes. So you can in NetApp, what is, if you're using like only for SAN protocol, right? So your nodes will be less. If you're using NAS, your nodes will be higher. Many more nodes you can use. Okay. And this is the maximum capacity, 35 petabyte. And this is the unit size, like form factor, like during the time of the rack size, like Almira size is there, right? So that kind of like So here expansion slots, okay, PCI expansion slots. Here it will be like your 32 GB FC ports, 16 you can have. You do not have any 16 GB FC ports here in this AFF250, A250. Okay, here FC ports are not there. You will have 1000 GPS ports, okay, 400 GB, GB per Ethernet ports, okay. You can have 25 GB ports, 20 ports, okay. 10 GPS ports is not there, so you can see this. These are all the backend ports which will have 10 GB or 6 Gbps SAS connectivity, okay. And network supported is lot of these things are supported. CFS, I will show you CFS. I will show you this is in object storage. I will show you this. NetApp supports its own object storage like StorageGate. It also supports Amazon Azure Google Cloud object storages. It has NFS, it has iSCSI, it has FC, NVMe. This will I'll show you. NVMe, FC I'll show you, okay. And here ONTAP version is supported up, like the lowest ONTAP version will be 9.8, okay. And this is a shelf model. Here you can have 24 drives, 24 small form factor NVMe drives, which is very fast drives. And this is 2.5 inch like disk, like small form factor disk, like 24 drives you can have. So this is different models of your disk shelves. You can use either of them or both of them, okay. These are the open system that you can support. You can see here mainframe is not supported, okay. Mainframe is not supported in this NetApp product, okay. Power consumption also you can see. So these are the specification. Here they have not mentioned the NVRAM size, okay. So I'll just check in some documents, NetApp documents. I'll let you know, okay, what is the NVRAM size, okay. So as I said, cache it will give you better response time whenever the data is in cache, okay. So cache will improve your storage system performance because it is isolating the host from mechanical delay. Suppose you have SASD or SATA disk, right? So whenever you are having any read request and you want to get the data from your disk, right? So the disk, you will have spindle, you will have rotator. So you need to locate the data in the sector of your rotators, and once the data is located by the head, then only it can stay the data to the cache and you'll get the response. So that will have some mechanical delays and it will increase your latency, which you don't want that. So that's the reason cache is very important, okay. Because so whenever I discuss this in first session, what is RPM, rotations per minute, like how many rotations a disk will have per second. And I also discuss about seek time. Seek time means how much time does it require for the head disk disk head to locate the data on the platter sector. So that is the seek time. So this, because of these seek times and rotation latency, your response time will be higher. And if the cache you are using, so you will get faster response, okay. Whenever write request is coming, then it will be first written to the cache and the host will get acknowledgement, okay, written is data is written to the storage, but at later point of time data will be staged to the disk. So the host is devoid of any mechanical delay of the disk. But nowadays I'll tell you a very funny thing. Because of the SSD disk, cache's benefit is getting reduced because SSD is very fast, okay. But still cache is important, but it's getting lesser important nowadays. It was more important in earlier days because the mechanical disk was slower, so cache was more important. But nowadays it's lesser important because the SSD is very fast and the price of electronic devices is getting lesser and lesser. So SSD is very low price, so that's the reason nobody wants to buy SAS or SATA. They will get SSD disk instead, okay. Okay, so then let me talk more about the cache. This is the architecture of cache, okay. So basically the cache will be organized into pages or slots, okay. What is page or slot? It is the smallest unit of cache allocation, okay. And the size of the cache, this cache page will be as per the application input output size What is, suppose it's a 32 KB, so the page will be 32 KB, it's a 64 KB, so 64 KB, like that, okay? And the cache will also have two more things. One is data store and one is diagram, okay? So what is data store? Data store is the component in cache which will hold the data, okay? And diagram is basically metadata. Metadata means it will have the location of the data, like how the data is stored in the cache, right? So it will consist of the metadata, okay? I'll tell you one thing. Metadata is more important in cache, it's more important in NAS, but it's not that much important in SAN. In SAN, you have logical block address, you have LBA, block addressing. You do not have metadata informations. You do not have that much overhead in SAN, okay? NAS, we have metadata. Okay, in object storage also we have metadata. Okay, so that's something, they will not ask you this, but I'm just telling you as much information as I can give you, so that you can understand the storage well. Once you understand the basics, you'll be able to
Yeah,
do anything.
actually, I read about WAFL in NetApp. So when I go through it, so there they're showing their metadata. They are not storing the metadata when they are using the WFL. So is it same with the cache or it directly connected with the physical disk only?
Yes, it is right. This information that I'm telling is, it's actually generalized in architecture, okay? But in NetApp, they're using WAFL file system, right in your file system. So what they're doing, if some new data is coming, they're just giving the pointers to the data. They're just doing pointing. They're not doing that. They're just giving pointing to the data. So why they're doing this? So that your write penalty is less. So I discussed about write penalty in one of the sessions. So I'll discuss about the waffle. The architecture of NetApp is different, but this is something you have to know. This is the basic architecture that you need to know for all the storages.
Oh, okay.
Okay,
I thought
this is the basic
we are
architecture.
discussing about NetApp. Okay. Good. Yeah.
No, once I discuss about storage basics, then I'll go to NetApp.
Okay.
Then the NetApp I'll discuss about the differences. So this is the architecture of, NetApp, like 7 mode time, not 7 mode also, even 7 mode they have waffle. So it discussed about cache, EMC, Hitachi, all these things. In NetApp also they are using. Okay, so NetApp also similar to these pages, all these things will be there, okay, but the terms will be different. I will tell you this, okay. But when you have the interview, right, if you tell them this, they will be very happy to have these informations, okay. Depending on company, they'll ask you different things. Okay, so here you have the data store. So data store will keep the data in the cache. It is basically the user data, okay, and the diagram will keep the location of the data, how it is stored in the cache. So it is the metadata, okay. So what will the entries in the diagram? So it will indicate where the data is found in the cache, okay, and it will also indicate where the data is located on the disk. So it will indicate both the things, right, how it is located in the cache and how it is located in the disk, okay. So this thing is there, and this diagram will also have a dirty bit flag, okay, dirty bit flag, okay, dirty.
Sir, do they ask these questions about cache in the interviews, and is it important for us to know these details?
Yeah, it depends on. One of the interviews asked me, okay, there was one of the interviewer, she asked me, write cache, read it, cache, write it, read through cache, write back cache. He asked me these questions, and they will ask you these questions more if you're an L2. For L3, they won't ask these questions
Right.
because they want to. Yeah, they will only have half an hour. They
Oh,
will probably be busy in meeting or something. They don't want. But in some companies like product-based companies like Hitachi, NetApp, right? They'll ask a lot of questions. In Hitachi, when I used to work, right, you'll be surprised to see, whenever I meet people, right, that their team leads, I know them, whatever company it is. I know them, like it's like normal. Like Hitachi also, I know them. Even Capgemini, HCL, lot of different companies. So I always feel I always get some common people. So I'll tell you one thing. NetApp is the very good storage. You will have more jobs in NetApp compared to other storages. Okay. if you learn NetApp, if you can work on NetApp, then you can work in any storage, because all other storages are easier compared to NetApp, except mainframe storage. Mainframe storage is different. Okay, so this diagram will have some dirty bit flag. Okay, what this dirty bit flag is? So this dirty bit flag will have the informations like whether the data is, whether the data that is in cache, it has been committed, committed to the disk, means it has been destaged, written to the disk, or destaged to the disk. Okay, so it will have this informations. Okay, and also it will have this informations like when the last time this data was accessed by the server. Okay, and if the data is not accessed for a long period of time, then your data can be destaged from your cache, or data can be moved from your cache to your local disk. Okay, to your storage disk. Okay, so you can do that. Okay, so what normally it will do, so whenever any read request comes from the host, right, so it will be processed by the front-end ports, front-end controllers. The front-end controllers will access the tag RAM. Okay, and using this tag RAM, it will determine whether the data is in cache. Okay, if the data is in cache, then this operation will be called as read heat. They will ask you what is read heat. Read heat means the data is in cache. The read operations, whenever doing read operations like server team is doing, then the data, if the data is in cache, that means it's read heat. Okay, read heat or read cache heat. Okay, and then directly from the cache, the data will be copied to the host. Okay, and the host will get an acknowledgement the data is data, then the host will get an acknowledgement and the read operation will be completed. Okay, so in that case you will get a fast response to the host, so it will get like 1 millisecond, 2 millisecond. But if the data is not in cache, okay, then what it will happen, then it will be called as cache miss. Okay, so then you have to stage the data. It is called a staging process. They will ask you what is staging. During the interview they will ask you what is staging, what is destaging. Okay, destaging, they will ask you this thing. Okay, so when the data is not in cache, so using the tag rank information, so dirty bit flag, it has the location where the data is located or committed on the disk, so it will stage the data from the disk to the cache. Okay, and from the cache the data will be sent to the servers by the front-end ports or front-end controllers. Okay, so as the cache is missed, right, because we are not able to get the data from cache, because of the cache miss, the response time, the input output response time will be higher. It will be 4 times than the cache, if it is cache hit. Okay, read it. Okay, so this is something that you have to know. Okay, and there is one more thing that you have to know, that is, let me tell you this. Yeah, when you do work, right, you will be able to understand that how these basic things will help you. You won't understand now, you think that it's too much, but when you do the work, right, you will understand. Because whenever you do I'll tell you one thing, my juniors, right, they know how to do the work, but they don't know why they are doing it. One person knows, because I gave him the KT, so KT to both, but one person was able to capture it, so he knows. If you don't know why you are doing it, then you will do mistakes. And one thing you will do is, during the time of call, right, some issues, suppose you are on a shift and no other person is on a shift, your manager is calling, your client is keeping on a P1 P2 call, breach call, they are asking you some questions, you won't be able to tell confidently, so they will tell, okay, this guy does not know anything. They'll get a wrong impression. So that is the most important thing in infrastructure is communication skills. Your English communication skills should be good. Okay, it should be optimal. You need to know a lot of synonyms and antonyms. So anyway, so you see here, right, so here you see host is giving a read request. Okay, and the data is in, you can see the data is here, so it is being processed by the front-end controllers from the cache to host, so it's a read hit. And wherever the data is not here, it's on disk, so it is reading from the disk, and then going to the cache, and then from cache to the host, it's a read miss. Okay, read miss. So data not found in cache is read miss, data found in cache is read hit. So whenever you are getting some performance issues, you have to check latency and you have to check the data of read hit, read miss. If you are seeing lot of read miss or write miss, like the cache is full, the server is not able to write the data on cache, then you have some issues, storage issues. Okay, this is how you identify. If you know the basics, then only you will be able to identify the issues. Troubleshooting is very important because anybody can do the basic thing, but troubleshooting is where you will have your job, you will get better salary. Okay, so initially I had an interview with Infosys. I did not join the company, but they asked me about some basic troubleshooting things. Okay, so they gave me Pune location. I didn't join there, but just telling. Normally I attend the interviews just for the fun, just to see what they're asking. I will attend the interviews. Okay, so anyway, and this is read operations. Okay, read operations. Okay, and there is one more thing you have to do. So whenever you are doing read hit write, so there will be some read hit ratio or hit rate, which will be like percentage. Like you'll divide your read hits, so you have like 10 read hits divided by your total number of read requests. Okay, so read hit ratio is read hit ratio equal to number of read hits by total number of read requests. Okay, total number of read requests. So you'll get some graph, and then you'll understand whether the read request is it's being processed by the storage system properly or not, or there is some, maybe your cache is overutilized. You need to increase, you can expand the cache. Okay, but it has limitations. Limitation means one storage system will have some maximum limitation, but up to that maximum limitation you can increase, or you can get more nodes, more storage nodes or storage controllers up to the maximum. Okay, to have better read hits. So there will be some percentage, so that percentage graph will be there. From there you can easily identify whether there is some issue or not, performance issue or not. Okay, so if you get a higher read hit ratio, that means your read performance is better, your read performance is good. Okay, so that's what you have to know. And then I have to know, I'll tell you a lot of other things also. Yeah. So there are two things in terms of write operations. Okay, write operations in cache. Okay, there are two things there. One is write back cache. Okay, and there is write through cache. Write back cache and write through cache. Okay, suppose you are doing the write operations. Okay, and whenever your cache like NVRAM space is there, and you are able to whenever server is doing some write input output, and it is able to do the write it is able to do the write in the NVRAM or cache, and then it will get an acknowledgement and your write will be completed. So it will take far less time, depending on the host. So the host will get lesser time to write the data, and if it is trying to write the data on the disk, so it will take more time, because it has to again the input operations, it has to again traverse through your backend ports. Okay, which will take some time. If it is a mechanical disk, then it will take more time. Okay, so the writes are two types. Okay, sequential write, random writes. Okay, so sequential writes and random writes. Okay, sequential write means you are getting the whatever writes you are getting, it's written sequentially in the blocks, in striping manner, one block then one block. Random writes means it's here and there. Okay, maybe random writes. Okay, so if you're getting more, suppose some applications is doing more sequential write, right? So if smaller writes, if you're using cache, right? So what you can do, you can aggregate many smaller writes together for the large transfer, okay? So you can do that in cache. And cache, what you can do is that means, many smaller, suppose I will tell you one thing. Suppose in case of networking, right? So in case of like NAS, right? So you have a thing like maximum transfer unit, MTU. So if your MTU size is 9000, your Ethernet switches will be able to process more frame size. If it is less than 9000, like 1500, like, then it will be able to process less size. So it's called, the bigger frame will call it as jumbo frame, okay? Jumbo frames, like bigger size frames, okay? So jumbo frames, if it is able to transfer the jumbo frames, so it will take lesser time, okay? So the cache, there are two things in cache, like for write operations. One is write back cache, okay, and is write through cache, okay? So what is write back cache? Write back cache means whenever host is doing input output, it is writing the data on the cache, and the host is getting an acknowledgement that write is completed, okay? And at later point of time, data from the cache, like several writes from the cache, it will be destaged or it will be committed to the disk, okay? So here the write response will be much faster, because there are no mechanical delays which you can get from the SAS and SATA disk, okay? But there is one problem. Suppose you have some you have the data in cache, and the cache, like you got power outage, right? So the uncommitted data, right, you lose the data if you do not have vaulting. Normally all the intelligent storage system, like enterprise storage system, they will have vaulting. So if you do not have it, so you lose the data. But normally you have the vaulting, so you will have the data, okay? In case of EMC, they have some SSD disk where they vault the data, okay, for PowerMax, okay? So like this. NetApp also, they have something, okay? They have the vaulting mechanism, so they will keep the data there, and in case of power outage of the controller, they can do that. And normally NetApp, what happens that anyway your NVRAM is mirrored, to the other controller, so you don't need that. NVRAM is already mirrored, but still you will have vaulting, okay? Now there is one more thing, which is write through cache, okay? Write through cache, okay? So what does it mean? What is write through cache? So whenever you are writing the data on the cache, and immediately if the from the data from cache is committed to the disk, okay, and then acknowledgement is getting to the host, then it is write through cache, means it is writing through the cache, okay? So because your data is committed, whenever you are getting the data from, trying to write the data from cache, okay, so the data loss, like you are not losing the data because the data is always committed to the disk, but your response time is much longer. Your response time is much longer because you have mechanical delays from the disk, okay? Okay, so that is something there, okay? So in cache, there are two things in cache. One is dedicated cache, one is global cache. In Hitachi, they use they use global cache. In NetApp, we use like dedicated NVRAM, okay? So that is there. Global cache means both the controllers will be using the same cache, okay? It will be just using the same cache, okay? That's a global cache, okay? So that is something there, okay? Okay. So there are two things in Jaychan, please unmute yourself. Sorry, mute yourself. Okay. So there are two things in cache. One is cache vaulting and one is cache mirroring. Cache mirroring is done in NetApp. Okay. So what is cache mirroring? Cache mirroring means whatever write the server is doing on the cache, it will be copied to two different memory locations, okay? In NetApp, what will happen? Suppose you have two node controller, like two node cluster. So you'll have two nodes or two controllers. So every node will have the NVRAM. So data is written, suppose a volume is owned by one node. So whatever data is written to the node, it will be copied to the other NVRAM, okay? So that is called mirroring, okay? So your write data will be in the middle location, so it is safe, okay, and then it will be committed disks, okay. So whenever you are trying to read the data from the disk, okay, you can directly read it, okay. Whenever the data, like whenever is a cache failure, you don't worry about it, because anyway your writes are mirrored and you're not going to lose both the controllers at the same time. So you have the data redundancy in cache, okay. So here there is a concept like cache. In cache vault mirroring, there is a concept, they call it as cache coherency, okay. So what is cache coherency? Cache coherency means, suppose you want to write the data in both the cache, right, but it will be identical at all times, okay. The array will take the responsibility to ensure that the concurrent data is committed to both the NVRAM, okay. The data is same, so there will be no corruptions, okay. So that is called as cache coherency, okay. It's there in NetApp, okay. But in case of EMC and Hitachi, you have this concept cache vaulting, okay. Cache vaulting, okay. I'll tell you one thing. Suppose your interviewer is a person who is new to NetApp, he is taking a NetApp interview, so he'll ask you a lot of questions, okay. So even though he won't ask you from this, but basic question he'll ask you, and he will not even recognize that whatever he's asking, he will think that he is the one who knows everything, okay. That's why you have to be smart, you have to know a lot of things, you have to at least know the basics, okay. So what is cache vaulting? Suppose you are writing a data to cache and the data is not written on the disk yet, and you lose the power, the storage system lose the power, okay. It lost the power, maybe somebody unplugged the cable, or maybe some earthquake happened, or maybe some power outage happened because of the power supply got faulty, okay. So what happened? You can address this problem in many ways, multiple ways. So what you can do, you can have an alternate battery power, you can have so which can keep your alive, keep your array alive, okay. So that, and that array that battery power will be there, so that it will be there till the time you can commit the write from the cache to your disk. So that is one thing. So but whenever there is like extended power outage, like it is like for 5 or 6 hours, so at that time this battery is like using battery, this is not a valid option, it's not a viable option, okay. So suppose you have large amount of data which you need to write or destage to the disk or commit to the disk, okay. And the battery you have, it may not provide sufficient power for that, because it will require a lot of time to write the data, okay. So what storage vendor has done for that, they're using some physical sets of disk, okay. Mainly they're using SSD disk, where they can dump the content of the cache during the time of your power failure. This is called as cache vaulting, okay. And the disk, the SSD drives that you're using, is they're called as vault drives, okay. And when the power is restored, the data from this vault drives, it will be again written back to the cache, and from the cache it will be committed to your mechanical disk or SSD disk, your normal disk in the disk bay, okay. Disk bay means, I showed you this diagram, right? So this is disk bay, shelves you call it, okay. This is a shelf model, NS224, DS224, these are shelf models, okay. Okay. And here you see this backend, right? Here you see the backend, right? So what this backend does, so backend is providing an interface between the cache and your physical disk, okay. So this backend, what this backend will have, it will have backend ports and backend controllers. Backend controller means what? The processor in the backend ports, that is the backend controllers. In Hitachi they use Xeon processor. In NetApp I don't know what processor they use. In Hitachi they use Intel Xeon processor, okay. They won't ask you that, you just tell them that they use some processor, okay. So what it will do, so this, you are trying to transfer the data between a cache and physical disk, right? So this is this backend controller, the processor in your backend ports, it will do the control operations it will do, okay. So from cache the data will be written to the destination disk by the backend processors. Okay, and here the physical disk, it will be connected to the backends. Okay, so these backend controllers, it will communicate with the disk, whenever it's doing read and write operations, it will communicate to them. So there is one thing in NetApp or any other storage. Suppose you have a lot of disks, right? So one disk out, it will go to another disk in. So it is called at daisy chaining. Okay, they'll ask you what is daisy chaining. So one out of one disk will be connected to in of other disk. Okay, there will be output input, so it will be connected like this. It will be like daisy chaining process. Okay, so it will be like daisy chaining. Okay, so these are the things you need to know. And you, in the backend controller, is something, these backend controllers, this will do the encryption. Okay, this will provide the encryption. Okay, the encryption will be done by the backend controllers. So in NetApp, I will take a session on encryption. There is onboard key encryption and external key encryption. I will teach you about onboard key encryption, which is the popular, which is mostly widely used. Okay, and I also give you the concept about external key encryptions. So the encryption will be happen by the, it will do this by the backend controllers. Okay, backend controllers. What these backend controllers will do, these backend controllers will provide the RAID functionality. Like here it will be RAID, right? The disk will be RAID, right? But it will just do the control operations of RAID. So RAID, rebuilding, all these things. So it will do the control operations. Okay, that it will do. Okay, and normally in NetApp or Hitachi, we use SAS backend. We call it as SAS backend. So you'll see a thing like SAS backend. Let me show you this. I think I probably have it somewhere. Here probably. No, not here is there. But here you'll see some SAS backend. Okay, inside of this you'll see some SAS backend. So you'll not be able to see clearly how the disks are connected because it will be hidden from the public view. There will be one like big like kind of pipe. I went to the Hitachi Vantara data center in Bangalore. Okay, so it's like a pipe. So like kind of like a pipe, big black pipe, and then inside of this it will be connected. You won't be able to see that unless you open the pipe. Okay, so it will be like SAS backend. Okay, so nowadays they have created NVMe backend also. It's a latest invention, NVMe backend, which gives you, like I told you, like backward compatibility, all these things, right? So just check my first session, backward compatibility about these things. Okay, so like SAS is backward compatible or SATA is, so all this thing you just check there. Okay, so here what is happening is this SAS backend will be there, right? And even the physical disk will have like this controller, what you are having like backend controller, right? It will have like alternate path. It will also have multiple paths so that it can eradicate the single point of failure. Okay, basically all the disks will be dual ported. Okay, so that's the thing. Okay, it will be connect. So what I'm saying is this suppose this is a 4-node cluster, right? So you can see here node 1, this is one cluster, one controller, this is another controller. So this shelves is connected to this node and also the partner node, because these both are in HA pair, high availability pair, means these are in cluster. Once this is down, this is the node or controller which will take over the operations of this disk shelves. Okay, DS, disk shelves. Okay, in Hitachi you call it as disk units, in NetApp is disk shelves. You have bay ID, shelf ID. Okay, I will tell you all these things, so just you will be, all this information that I'm telling you now will be helpful in NetApp classes. You will understand. Okay, and then you have physical disk. I already spoke to you about physical disk in my first class, how the physical disk is there, like what kind of drives is there. So I already spoke to you about this. Okay, and I also spoke to you about LUN. What is LUN? It's a logical unit. Okay, means you can like a basic unit of your volumes. In NetApp, whatever you do, right? Suppose you want to create a share, the first thing you'll create is a volume, and then you create a share on top of volume. Suppose you want to create LUN, then you create a volume, and top of volume you create a LUN. Okay, so that's what you do. Okay, so we'll talk about this again in next session. We'll talk about more about LUN masking. Okay, and then we'll go to more about switch part. Okay, then once this all these things is done, then I will go to the NetApp part, NetApp architecture, how the data flow happens, then go to the networking part of NetApp. It will take some time. Okay, so guys, you understood, right? So front-end port is for replication and zoning. Back-end port is to connect the disk, and you'll have dual ports for redundancy purpose. Cache is for performance enhancement. Read it, write it. Okay, so these are like these are like, you know, interchangeable for all the storages. Okay, so guys, did you understand? Do you have any questions? If you have any questions, you can ask me. Okay, these things I will discuss it tomorrow. Okay, how the LUN masking happens. Okay, how the presentation happens. So here the logical, the LUN number, LUN ID will be different data, and when you go to the West, it will be different. Okay, if you use some proprietary multipathing software of your storage vendor, then you can see the LDOID of storage system in the server itself. But if you're using a native multipathing like MPA or multipath, then you cannot see it. But in case of EMC, you can convert this because you'll get a big UID. You can convert that ID. There is some operation that you can do to convert the ID. Even for Hitachi also you can convert. Okay, so anyway, so guys, do you have any questions?
No.
Please feel free to ask if you have any questions.
No.
So let me ask you some questions. What is front-end port? Why do you use front-end port?
The front-end port is the mainly disk, not nodes.
What is it? Maybe?
It is used for the replication and NFS.
Yeah, it is used for provisioning purpose. It can be SAN or NAS. It is NAS, then you'll use Ethernet ports. It is SAN, you'll use FC or iSCSI ports. Front-end port is not disk. Disk is here. You connect disk with back-end ports. Front-end ports, you connect server with front-end ports. Switch server with front-end ports. In case of replication, you connect another storage with front-end ports. Another storage front-end port with this front-end port. Front-end port is not connected with disk. Back-end port is connected with disk. That's why I'm giving you basics, because without basics, you will you cannot do the work. You can do the work, yes, you can do the work, but you won't be able to clear the interview, or you won't be able to do troubleshooting, because you won't be able to understand what you are doing, or like why you are doing. Sorry. So front-end port is for provisioning. Provisioning means allocation, storage allocation. It can be SAN, it can be NAS. Backend port is connecting the disk with your storage controllers. That is backend port. Here you will have SAS expander. This backend is SAS backend. This front end is FC front end, or it can be Ethernet also. Front end port is connected with your server and cache. Backend port is cache, it is doing the data transfer between cache and physical disk. Front-end port between your host and cache. Okay. So what is cache and why do we need cache?
That improves the input-output performances.
Yes. Yes.
Yeah, there
And suppose
and that front-end ports are connected with switch, na?
yes.
Yeah.
If you are using SAN, you'll be connecting this with SAN switch.
Fabric switch.
If you're using NAS, fabric
Ethernet
switch.
Yeah.
Fabrics. If you're using NAS, you'll be connecting this to Ethernet
Ethernet
switches
switch,
or
yeah.
network switches.
Okay.
And in NAS, you don't do zoning. Only SAN, you do zoning. And that is only for FC. For iSCSI, you don't do zoning. Because for
Yeah.
iSCSI, you are using Ethernet switches. Normally you will not use iSCSI, bro, because performance is bad. I'm using iSCSI for one CAD application Hitachi for Coram device. So that is a different concept. So the thing is, what you need to do, you need to just spend time and learn. That's it. It is very easy thing. You just have to learn how you are doing it, why you are doing it, and you are doing it. You are not inventing it. It's not like coding. You are using some algorithm, something. When I give automation classes, right, I don't care about algorithm. I just want the automation script to work. That's it. My brother-in-law, he cares about algorithm because he's a Node.js developer, like React.js developer. So he cares about algorithm. Okay. But I don't. We in automation we don't care about algorithm. It can be a slower code. It can be run like it can take much time to run. It's not a problem. It just has to automate. That's all. Okay. So what I can ask? What is multipathing? What is multipathing? I think this is better. Every session I'll ask you some questions so that you can clear your basics. What is? These are the questions. What I'm asking you, right? They will ask it in the interview. What is multipathing? What is multipathing software and why do you use multipathing software?
To get the redundant path. So
Yes, yes. So that even though you are having multiple paths, still the server will not be able to use the storage efficiently in multiple alternate paths. So you need to use multipathing software. So what are the multipathing software available? So what is native multipathing and proprietary multipathing? Vendor specific multipathing. You can easily answer. Just try first.
when we are using third party storage, then we are going for the software multipathing. And when we are using the same vendor, so in that time we are going for
Yeah, you are right. You are right. But this not software multipathing. It's proprietary, vendor specific. So what you are doing is native multipathing means it comes pre-packaged with your operating system. Windows is having MPIO, Unix is having multipath D. And if you're using vendor specific, you can do that. But in our environment, or I have seen in many environments, we are only using native multipathing, okay? Not vendor specific, okay? Native multipathing we're using,
okay.
okay? So that is thing, okay? Multipathing is very important. You need to make sure for multipathing software, is it used for SAN or NAS? There's another question.
SAN.
Is it used for
It is using for
yes,
SAN.
it is used for SAN.
That
Yes,
is for
SAN. So why do you require? Because suppose you want to do some switch upgrade. I'm just giving an example. There will be multiple examples. Suppose you want to do switch upgrade. So what you will do? You will have the switch in both fabric A, fabric B. You want to do one in fabric A. So you need to ensure that when one switch is down, another switch is there, which can do your server can do input operations using that switch. Okay. So you need to make sure multipathing is there. So you need to send an email or better raise a service request. খাওয়া দিয়ে দাও খিদে পেয়ে গেছে খাওয়া দিয়ে দাও হয়ে গেছে আমার খাওয়া দিয়ে দাও Actually, I'm sorry, somebody in the class, he told me that he's have meeting in 9:30. I think I've extended the training beyond that. Uh, so that's something which is not good, but anyway. So please, please accept all the participants. So, yeah. So what I was asking, yeah. So after every topic, right? So I will ask you some questions which they will ask you in the interview, okay? So I'll ask you these questions because one of my students, Ridip, okay, Ridip, he works in Kindle. He's very good in storage. He's like an architect in IBM storage, okay? So he's learning NetApp, he's getting NetApp. So he asked me this thing. So I think there's a proper way, because until unless you use the training if the training is not benefiting you, then it's useless. So that's the reason. And I only learn things that I can use in my project, or things. I don't learn things that I don't use. Okay. So multipathing. Okay. So anyway, so you need to make sure that multipathing is installed for all the servers for SAN. Okay, multipathing is required, and even multipathing is required for iSCSI also. Okay, for iSCSI also multipathing required. It's a SAN only. You require multipathing. And NetApp, I'll give you example. Like without multipathing, you cannot make sure about workload distribution for your SAN storage in NetApp. Okay, but for NAS, some other IP based load balancing is there. Okay, I'll give you I'll tell you all these things. NetApp is a very big chapter. Right? Okay, so I wanted to keep more training, but I think I won't be able to do. Like I want to take more topics, but I think I will not be able to. Like topics means like storages like NetApp Hitachi. So I'm only doing NetApp Hitachi, okay, and automations and SAN switch. So these are all I'm doing. So I've requested my friend to do ISL and all these things. So because if I'm trying to train some people correctly, right, it will take a lot of time. So that's the thing. Okay, so what I ask you is that you just revise all the sessions, okay? And one more thing. So I'll give you this. So guys, one thing I will do. I will give you the access. Okay, just copy your user ID, sorry, email ID, and just take the access from here. Okay. Take the access of the previous videos. Okay, so just one second, let me go to my playlist. Where it is, what is NetApp, this one, training on storage. And so guys, who wants to go for that, just or maybe you can just tell me the let me just